Sir, I welcome you to this TLC.
Thank you.
I think you might be knowing that this particular studio is established right now with a set of equipments. We wanted to basically make this studio as a SWAYAM compliant studio. So all the equipments and whatever we have, these cameras, they are actually compliant with SWAYAM guidelines. So we can offer large scale, massive open online courses using the SWAYAM. So I think, so being the first shoot here, and we are becoming we are getting late because of the adjustments and other things. So I think we can hopefully go into the interview straight away.
Yeah, sure.
So today, so we are going to discuss a few aspects of our teaching learning center. So to begin with, I think you are the one of the founder of this teaching learning center, and you established it in the early years. So I would like to get your perspective on a few of the aspects about how teaching learning process can innovate using makerspaces, and what is the core philosophies of our TLC and core activities of the TLC, and how in this today's context, we are looking at China being a dominant player in manufacturing. How can we take on China and then make self-reliant Indian educational technological, especially products used for innovative design and manufacturing education? So I would like to get a few perspectives from you, sir. And the first, to begin with, I want to ask you a question about project-based learning approach for teaching learning process. So one of the important impediment to engineering education in India is about having low cost and affordable equipments.
Yes.
So I think we envisaged a makerspace for teachers to make their educational technologies in an open source, affordable, do-it-yourself way. So why do you think that such a makerspace would help teachers to develop their own edutech?
Yes, as you said, the traditional way for our engineering teachers is to go for purchase of commercial, off-the-shelf lab equipment, etc. And the students don't get a clear understanding of what is behind the box. No? So it's like a black box for them. So and then if it is an imported equipment, it is very, very expensive, and anything goes wrong, it's difficult to repair, etc. And therefore, the modern approach is for the faculty to custom develop their own laboratory equipment, and based on this knowledge and experience and confidence, they can build their own research laboratory equipment, resources, etc. And for this, they need some basic tools and equipment and some common space. This is what we are encouraging to provide in the form of a makerspace. So our teaching learning center is designed to be a model makerspace where we have developed using the DIY or build your own approach, low cost desktop CNC machines, 3D printers, laser cutters, etc. So therefore, the teachers who visit the TLC, who undergo our workshops, training courses, etc. So they gain the confidence and motivation to build such equipment for themselves, either by replicating our technologies or customizing them for their needs.
Okay, so the philosophy that we follow is usually called as DIY.
Yeah.
That means the teacher comes here, maybe he by himself or with a set of really bright students.
Yes.
They come here and then they take up a manual and then they build the machines by themselves.
Yes.
So why do you think that this DIY philosophy will help teachers become innovative? So what is that so good about DIY being adopted into this TLC?
Yes, as you said, teachers have the option to come, spend a few days with their practically skilled students, and then we provide instruction manuals for assembly of this DIY equipment that we have already developed. And then they just purchase the components as per our shopping list, etc. And then they come here and then take the help of the TLC staff and then reproduce the machines, test them, and then they take them back. The advantage with this approach is that the equipment cost is about a fraction of the cost of even Indian commercial equipment. And then anything goes wrong, you can repair it yourself because you have built it. And then you can make bigger, more powerful systems, or you can customize them for your needs. So you build a 3D printer or a CNC machine. So you can convert it into a fluid extruder, microfluidics machine, etc. Then you can build a CNC, textile.
So there is a whole wealth
yeah.
of opportunities for the teachers
Yes.
once they learn the basic machines, how to
Yes.
build it.
Yeah.
So they gain a confidence, and then they go back and then
Yeah.
they actually modify the existing designs to suit, even build their own research equipment.
Yes.
I think that's what you mean.
Yes. So and then in addition to building this research equipment, laboratory equipment, etc., they can go out into the real world, talk to local industries, companies, etc. And then many of them, they use similar equipment, because the CNC 3D printers are becoming common equipment in the factory floor. And therefore, the faculty can take up consultancy projects, research projects to solve the problems faced by them, etc. And then eventually develop Make in India alternatives to the imported model, even in industry.
That brings a very important question.
Yeah.
So today, in this context of COVID-19 and situations that we right now go through,
Yes.
India is looking at more self-reliant technologies.
Yes.
Especially we envisage to become the world leaders in the next generation manufacturing. So how do you think that teachers can enable students to become the next entrepreneurs in building self-reliant technology, especially in the educational sector and educational technology? So how do we think that such a makerspace will provide teachers innovative tools to educate students to become them entrepreneurs in the future?
Yes. Again, there's a lot of R&D has already been done in the area of educational technologies. And then nowadays you have this excellent resources of open source hardware and software. So therefore, it has become fairly straightforward for teachers to look up how to rebuild. We are not reinventing the wheel, because it has already been done, including by us in the Teaching Learning Center. Many students and faculty from universities, IIT, or polytechnics, they have already come here, built our machines, taken them back, and then they are using them happily. So therefore, the students can now look into the DIY educational technology as a commercialization or a startup option, because we have got hundreds and thousands of polytechnics, ITIs, colleges, universities, etc. And most of them, they have very minimal equipment for manufacturing technology education. Okay. So therefore, like we have built a plasma cutter, low-cost plasma cutter, which you can convert that into a welding machine. Then we have built laser cutters, which you can convert that into a metal engraver, laser engraver, etc. Similarly, the CNC machine, 3-axis CNC machine, you can add a 4th axis or even a 5th axis, so that you can do complete subtractive manufacturing.
And even some of these equipments, I think, are the size which is minimalistic, which could be even taken into a classroom for a practice education. So it could be blended into a classroom or not just in a laboratory or a practice course. So this brings in another important question about the role of using open source equipments, or we call this manufacturing technology education equipments. So inside the classroom, what do you think about it?
Yes, actually whenever the TLC staff, they conduct on-site workshops on CNC, 3D printer, etc., they have this concept of CNC in a bag or 3D printer in a bag. You just take the basic frame with attachment, it's a minimal attachment, and then go and open it up in front of the students and faculty, and then complete the assembly, and then show it to them. So this gives the students the confidence to do that. So this is one end. You can have a smaller machine which are easier to try, portable, and then demonstrate. But then in the future, you can build bigger and better machines, more powerful machines. That is again, that gives a lot of options and opportunities for the teachers and students who are interested in entrepreneurship. Because there's a lot of scope for indigenous technologies, even in small and medium manufacturing industries. For example, many people are using Chinese-made routers, CNC routers, which are basically CNC machines, but they're on a bigger bed with bigger
larger
motors.
power.
And you can still make them cheaper than the imported versions. And then the problem that the industries face is whenever something goes wrong with these machines, it's difficult, it's almost impossible to get them repaired because the manufacturer is outside the country. So therefore, you can make these kinds of improvements, adaptation, etc. So the CNC plasma cutter we have built, you can easily have a CNC welder, 3-axis CNC welding machine you can build. So that you can automate the welding process, make it more accurate, make it more productive. Therefore, the company's profit margin goes up, then the quality is improved, etc. There's lots of such opportunities. Only thing is the faculty and the students need the some initial pointers or some motivation that these openings are there, these opportunities are there, and it is not a very difficult process to do. Therefore, we want to be facilitator of this kind of indigenous manufacturing education.
Yeah, that's a great insight into how such a makerspace could help teachers build their own equipments.
Yes.
That too is so portable so that they can actually carry it in a bag and then walk into a class and use them in regular instructions of manufacturing education.
Yes.
So, so another dimension that I want to talk to you is about, we were always talking about schools outreach.
Yes.
So what you think is the right age for someone to begin a manufacturing education? Because we have been doing a lot of outreach with schools. So, and also we are looking at ITAs and polytechnics. There is a notion of vocational education. Vocational education should be part of the main curriculum. So there is a new education policy which also advocates the use of vocational education and use of manufacturing technology hands-on. So what age you think is the right age to begin such an education, and how do we think such makerspaces at schools can help teachers enable students to do such a kind of activity and build projects?
Yes, that's an excellent question, because the government is talking about vocationalizing education, but you can't vocationalize education unless the teachers and students, they have actual equipment to lay their hands on, so that you can disassemble it, then you can put it back, and then you can hack it, you can modify it, you can improve it, etc. For that you need actual machines, at least to start with. Some desktop machines, small machine that you can take it in a bag and then demonstrate, etc. Whereas currently, as you might be familiar, in most engineering colleges, polytechnics, even ITIs, the manufacturing education technology is taught in a demonstration mode. There are only 1 or 2 machines. They just, the laboratory technician will do a demo of the machine. This is how it works. Then the students do all the manufacturing and machining, etc. in computer software. It doesn't give them a feel for
They never wet their hands with the real machine.
Because
they just see the simulation and they are shown how the machine works in a group, and then they disperse, because this equipment is costly, the consumable is costly, and the machine maintenance have an issue, because if they allow the students, if the students does something wrong, they always have this fear of spending extra bucks about getting the machine repaired, and all those aspects of that.
And then unless you use the actual machine, for example, the feed rates or spindle speeds, etc. that you set, that changes on the material. Wood has one set of rates, and then suppose the bits are not fresh, they are a little bit degraded, etc. The machining quality changes. So you can't get a feel for this real world effects unless you actually work with the machine. So therefore, we have brought down the cost of this machine to a fraction of the cost of the commercial machine, because you don't need really a huge industry grade CNC machine or 3D printer for learning these things. So you can, the students can actually machine something or 3D printing something, and then at a cheap price, then they can take it home. They can show it, explain these things to the parents or keep it in display, etc. So it gives them the happiness of some accomplishment. Okay, they built something. Whereas now it doesn't happen in the
So there's a sense of feeling of completeness when they do something hands-on. Something works when they do it. Something they feel a sense of, I would say,
the pride is there, that I have built something.
Creation that I created, something which really works in the real world.
It gives them, it also gives them a motivation for why they are in engineering. For example, one of the projects we did in the TLC was to have a prototype braille printer. Braille printers are not made in India, they are still being imported, and therefore the interns, they built a small Braille
So
printer, which
that
is
brings-
basically a CNC machine.
Yeah, that brings another question.
Yeah.
Like we are always talking about manufacturing education. So what impacts that you see, that like for example it should be a social impact like you were talking about, helping the physically challenged or visually challenged people, or so how do you think that social impact can be created by the maker spaces?
Yes, so for that, we need to go out into the real world, talk to the potential users, stakeholders. For example, you go to a school for blind children, or you go to a school for autistic children. So in that case, you can come up with virtual reality technologies. Therefore, the children interact, the autistic children interact with the virtual world, because they shrink away from interacting with the in the real world. They are they withdraw into themselves, whereas they are more free dealing with objects and worlds in the virtual reality. Therefore, such opportunities are there. So we can similarly we can go to we have done some consultancy projects for textile industry, etc. So therefore, the same components, the same sensors, microcontrollers, microcomputers, etc. You can use them for different applications. It's like basically the process of cooking. The ingredients are more or less similar. You just have them in different combination. Then different
We get different cuisines
from so different recipes. Then you come up with different food items. So it's very similar. So for that, they have to go into the real world and then talk to potential customers, convince them. Then you can demonstrate some of the projects you have already done, so that they are interested in funding your consultancy. So there's lots of such opportunities out there, because many times they are purchasing equipment from abroad, they go wrong, then they just become junk, and therefore if it is done indigenously, it's a thing. And then coming back to the question of schools outreach that you mentioned. So what the TLCS try to do is to basically set up maker spaces, not just in colleges or polytechnics, but also in high schools, because nowadays this open source hardware is so easy to use. Even the tools are so inexpensive, power tools, hand tools, etc. They're so inexpensive. So even children can build a 3D printer or CNC machine, or we have already been doing is that follow the overseas approach of setting up STEM labs, science, technology, engineering, and mathematics, or STEAM labs, science, technology, engineering, art, and math labs in schools, because these technologies are so simple and even kid friendly that children in as early as 5th standard or 6th standard, they can do 3D modeling with open source computer-aided design software from top companies like Autodesk or SolidWorks. Then they can take computer-aided machine software and then send this output to a CNC machine or 3D printer. Then you can have a 3D model that you can take home, show off to the parents or relatives or friends, so that you feel the sense of pride, that you built something. That is very important in terms of motivation for the children to learn, why they have to learn these concepts. And then instead of doing abstract coding like they typically do in schools, like with some formulas or math, etc., you write the code for controlling a robot. Then it becomes more addictive. It's what we call playful learning. Children don't mind coding as much as they want or as hard as they want, provided they can see the embodiment in the motion of a robot, etc. Therefore, the way the coding is being taught in developed countries is through robotics, or through asking the children to build their own video game or animation or graphics, etc., which is much more appealing. So therefore, the learning outcomes are also much better. And therefore, what we have to do is to take this concept of makerspace for college or community or polytechnic, and then scale it down to school level, and then give the basic tools. Like children can also handle hand tools, power tools, 3D printers, CNC machines, all desktop machines. Then they can do something. They're working with metal, etc., as in college makerspace, they can work with plastic or woodworking, etc. in schools. Therefore, the learning outcomes are really improved. It complements them, and also the children can be engaged in the community. Like they can look for problems at the school level or at home or at the community level. Have, for example, a smart irrigation system for the school. So therefore, when the school is in vacation, still the garden is being kept well, and then they learn about the botany of gardens, and then they can go into smart systems, Internet of Things, all those things. They can be integrated into a single project that the children are capable of doing. So.
Yeah, I think you touched upon the point about co-creation, especially about social impact, reaching out to society, reaching out to NGOs where we can find problems and use technology to solve those problems. And also you told about the maker culture. So how that maker culture is very important to imbibe that into today's curriculum in schools. And we need to equip the teachers to give that information back to the students so early at a young age, so that they get lot of experiential learning when they touch and feel and then do programming. The hardware, learning programming through hardware is more, I would say, easier and then more reinforcing than using, let's say, programming using conventional algorithms. So that's a very good valid point. And I would like to ask you one more point about young teachers. So I believe TLC has been conducting regular induction training programs for faculty who have joined new into the institutions, and then trying to inculcate that perspective of innovative education through experiential learning and project-based learning. So would you like to tell a little bit about what we do with the young teachers here?
Yes, I mean, I don't want to stereotype it, but then the resistance to change or learning, the comfort level with learning new fields, etc. It reduces with age or experience. Therefore, the young faculty who have an entire career ahead of them, and also as the years go by, we have challenges like global warming, etc., which need desperate technological solutions at the community level or the local level, etc. So they provide a lot of opportunities for the young faculty. So therefore, they can learn with the students, work with the students, mentor them, motivate them. So by taking up such projects, and so instead of abstract or theoretical research that results in publications but does not really have a translational effect, in terms of what is this research has done to solve the problems of a local industry or an NGO or a community, etc. So therefore, this provides a lot of opportunity for the young faculty. They have the entire career ahead of them. So if they make a fine start, using the resources available in TLC, they can come here, work with our faculty, work with our staff, and then they can keep shuttling back and forth, and then they can build a mutually beneficial relationship with the teaching learning center, convince their home institutions to set up similar, if smaller scale makerspaces for the benefit of their students. Their students can come here, do internship, they can do their final year projects, staying in the institute and then taking your help. So it's a mutually beneficial opportunity, and then the young faculty, they can take a lead.
Okay. Yeah. And finally, I would like to talk about the impact aspect. We already talked about social impact, but looking at industrial impact, especially about the fourth industrial revolution, there are 8 technologies which has been identified as the key core technologies of Industry 4.0. Like advanced robotics, additive manufacturing, 3D printing, augmented reality, and so forth, like blockchain and IoT. So our TLC's main thrust focus has been among all these areas. So what would you like to say that how industrial impact by enabling teachers to develop next generation engineers, training them to work for the next generation smart factories?
Yes, see the smart manufacturing, industrial IoT, etc. The core components for all these technologies pretty much the same. You have mechanical body, and then you have sensors to monitor the condition. Then you have electronics or the hardware. Then you have the software, which is the heart of it. And then increasingly we add intelligence into the system in the form of algorithms, and by crunching the data, big data that the system produces, etc. So therefore, whether it is smart manufacturing or industrial IoT, etc., or you can take this into the field, the precision agriculture, as the water becomes precious commodity in the event of global warming, etc. You want to use water in precise quantities along with pesticides and fertilizers without damaging the soil and the ecosystem. So therefore, you can take the technology from one discipline, the same sensors and mechanical frame or a robot or whatever, and then change the algorithm, change the model, etc., and then apply this solution in multiple fields. So therefore, again, the basic technology they can train their students in, that is basic mechanical design, and then sensors, controllers, and then coding plus AI or machine learning or cognition, etc. And then it's all a question of system integration. So the system integration that you're doing, it depends on the domain in which you're going to play it, whether it is to help blind children or autistic children or the local farmer or your local manufacturing industry or maybe a government lab where they are looking for help from expert academics to work on some of their projects, etc. And then for the students also, it's a good opportunity because the innovation in the modern economy is all occurring at the interface between multiple disciplines. It's no more purely based on your own discipline. Like we have a field called Civionics. So Civionics is basically civil engineering plus electronics plus software plus sensors. So you can have a green building, you can have a smart building, etc. Similarly, we have a kinetic architecture. A lot of architecture nowadays is kinetic because the whole architecture can move according to the sensor data, even depending on the user with whom it interacts. It senses the mood of the user and then changes. So kinetic architecture. Similarly, we have kinetic art. Instead of stationary sculpture, you can move the sculpture using some motors and sensor data and then AI, etc. It's a very, very exciting field, which is very suitable, very motivational for the students to get involved. And therefore, it brings students from multiple departments together, so they can do a lot of brainstorming, etc. Then the other advantage that the faculty will provide the students is it gives them the soft skills or communication skills that is needed for their success in future career, because the students have to communicate with each other, so then do the brainstorming and then take decisions from ill-structured multi objective problems and then work on them and then have documentation of the progress and then the steps involved, etc. And then present them, like whether you want to present it at a competition to the judges or you want to go and pitch it to a venture capitalist who will fund this request for startup based on your innovative project, etc. So therefore, it's an excellent opportunity, and a lot of universities overseas, particularly in the United States, they all have innovation labs, makerspaces, whatever they call them. Like in schools, they have them. They call them STEAM or STEM lab, etc. So therefore, this is a very essential need of the hour if India is going to be competitive in the in the manufacturing sector. Not only manufacturing sector, also you can take it to the service sector. For example, you can take this mobile robot experience, try to build some e-rickshaws or autonomous vehicles.
COVID-19 times,
yes,
robotics has been used as nurses inside the hospitals.
Sure, yes. That is another excellent point, because people are talking about building a open source ventilator. So but what does this consist? It consists of the mechanical frame and then sensors and actuators in terms of pressurizing, etc. And then measuring it and then adapting it to different users depending on different stages, etc. So therefore, such projects the students can work on, and then they can like you mentioned the case of the mobile robot. So therefore, I think this is going to be there in the for some time in the near future, hopefully not so long into the future, that we want to keep social distancing. In that case, the robots are means for you to
even in every service sector, maybe in airlines, or
Yes.
maybe in restaurants, or maybe in hospitals, everywhere.
Exactly, because the service robotics is another major industry. Similarly, the knowledge that you gain in mobile robotics, you can take it into autonomous vehicles, automotive sector. You can have green vehicles, you can have electric vehicles, and then you can have self-driving vehicles, etc. And then these can be applied into other fields like defense or in agriculture, etc. So therefore, there's a lot of opportunities, and we are not going to be reinventing the wheel because a lot of progress has been done. We just need to learn the basics and then catch up with the rest of the world, and then progress and compete from
So
there.
one final question to end this interview.
Yes.
Indian defense manufacturing.
Yes.
So they are reaching a tipping point at one time. Now they have identified certain 20, I think 20 to 30 products they want to indigenize. So we have seen social sectors, we have seen industrial sectors. In defense or strategic manufacturing.
Yes.
So how do you think such a makerspace at school level can motivate students to even invent something at the defense kind of manufacturing setup? So can we reach some kind of a self-reliance in the defense manufacturing? So how do you think this will help to boost as a strategic sector, how it will help us to boost the local defense manufacturing?
Yes, as you rightly mentioned, a lot of products used by the armed forces, they are still being imported, they are expensive, whether it is submarine or a missile, etc. So, but we can make a modest start. So work on the design, whether it is some wearables, electronics, or some sensing equipment, or like ad hoc networks in the battlefield. Similarly, I have worked on underwater robotics. There are a lot of applications of underwater robots, surface vehicles, for monitoring the coastal area, for rescue, search and rescue operations, etc. So these are basically virgin territory still in India for the defense sector, because the defense sector is also limited in terms of manpower. Therefore, our academic community can work closely with the defense research and development establishment, and then help the soldiers and the nation in the process. There's again another opportunity field with a lot of opportunities.
I think TLC has made few contributions.
Yes.
I think through NRB funds and
yes, we have now developed some prototype autonomous surface vehicle, which is basically a mobile robot that is floating on the water surface. So therefore, again, a lot of opportunities are there. So people can take this into renewable energy, for example. You're just going to be operating the motor in reverse as a generator. So therefore, you can take this into renewable energy. You can go into environmental monitoring and control or remediation, etc. The opportunities are endless because the scope for innovation is endless. So what the TLC is doing is to give them the motivation or the exposure to the faculty and the students, so they get the confidence, then they get the excitement, and then the motivation in terms of opportunities. The faculty can get research publications, they can get patents, then they can work with the industry in terms of consultancy. Then the faculty and students, they can have their own startups industry. So then you have reliable consumers like the defense sector. So therefore, you are assured of success through your innovation. Yes.
So it was wonderful talking to you, sir.
Thank you.
Thank you for sparing your valuable
yes.
time
Yes,
for this interview.
Yes.
And I think I must thank you from the bottom of my heart. Thank you. Thank you.
Thank you very much. Thank you for the opportunity. I enjoyed talking
Thank
to
you.
So, and all the best for the success of the Teaching Learning Center.
Yeah, we are looking at you as a long time mentor for TLC and taking
Yes.
your inputs and everything that I do.
Thank
you
you
for joining.
Thank you.
Thank you.